If you're starting at this video, I recommend you go back to my video on related rates intro to really cover what related rates are and why we're going to solve them the way that we are in this video. Air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. Find the rate of change of the radius when the radius is 2 feet. Spherical balloon gives me a hint that we're probably going to use the formula for a sphere, and since we're filling this sphere, that would be volume of a sphere. Volume of a sphere is 4/3 pi r cubed. And that's our equation. But what's the given information? And what do we still need to find? The given information is that the rate at which the air is being pumped into the balloon is 4.5 cubic feet per minute. They didn't give us any sort of time, any conditions, so this is a constant rate. The air being pumped into the balloon is changing the volume of the balloon at a rate of 4.5 cubic feet per minute. So they've given a rate of change of the volume. This is dV dt. And that is 4.5 cubic feet, so feet cubed, per minute. And when I plug that in, I would like to plug it in as a fraction just because my equation already has fractions in it, so I don't like to mix fractions and decimals. That would be 9/2 cubic feet per minute. And what did they ask us to find? The rate of change of the radius when the radius is 2 feet. The rate of change of the radius, dr dt, when r equals 2 feet. We'll begin by implicitly differentiating the equation with respect to t. The derivative of the volume with respect to t is 4/3 times, pi is also a constant, 4/3 pi times the derivative with respect to t of r cubed. The derivative of the volume with respect to time is dv dt equals 4 pi thirds times 3r squared times the derivative of the inside, which is the derivative of r with respect to t. 3/3 is 1, so we have 4 pi r squared dr dt. They want us to find dr dt, so before I plug anything in, I am going to isolate dr dt by dividing both sides by 4 pi r squared. So dr dt is equal to 1/4 pi r squared times dv dt. They gave us the constant rate of change of the volume, which was 9/2 cubic feet per minute, and they asked us to find what is the rate of change of the radius when the radius is 2. 1/4 pi times 2 squared times 9/2 will simplify to be 9/32 pi. When you plug that into a calculator, you get approximately 0.09, and don't forget your units, okay? The volume was growing at cubic feet per minute, so the radius would be just growing by feet per minute. And that's how the radius is changing. Notice that the volume is increasing at a constant rate, but the radius is increasing at a variable rate, okay? Meaning the radius is growing more and more slowly as time increases. Just because two rates are related does not mean they are proportional. An airplane is flying on a flight path that will take it directly over a radar tracking station. If s is decreasing at a rate of 400 miles per hour when s equals 10 miles, what is the speed of the plane? Here we've been given a diagram that shows us a right triangle. And what we're relating for that right triangle is its side lengths. Do you know an equation that relates the side lengths of a right triangle? Pythagorean theorem. So the Pythagorean theorem would be a squared plus b squared equals c squared. But in our example, we have x, 6, and s being the hypotenuse. So x squared plus 6 squared is equal to s squared. What have we been given? If s is decreasing at a rate of 400 miles per hour when s is 10 miles, what is the speed of the plane? Okay, s is decreasing at a rate of 400 miles per hour. So that is a rate of change of s with respect to time, and it's decreasing, so it is a negative rate of 400 miles per hour. Under the condition that s is equal to 10 miles. So it's decreasing at a rate of negative 400 miles per hour when it's 10 miles long. And they're saying if it's decreasing when s is 10 miles, what is the speed of the plane? That's also asking what is the speed of the plane when s is 10 miles. Okay, so they've given you one value, one rate of change when s is 10 miles, but they want to know the speed. The variable that's changing here is the base, which is x. So they are asking us to find dx dt, the change of x with respect to time, when s is equal to 10 miles. First, I'll derive the original equation that we came up with, the Pythagorean theorem. X squared plus 6 squared is 36 is equal to s squared. Please make sure you know that's an s and not a 5. Derivative of x squared with respect to time is 2x times the derivative of the inside, which is dx dt, plus the derivative of 36. The derivative of a constant is 0. The derivative of s with respect to time is 2s times the derivative of the inside, which is ds dt. We're trying to find dx dt. So that's what I would like to isolate and then substitute the values that I know. So we'll divide both sides by 2x, which will make this an even simpler substitution of s over x times ds dt. So from here we have the given, which was the change of s with respect to time, is negative 400 miles per hour. And remember, this is because it's a velocity, so you can have a negative in it. Speed would always have a positive when s is equal to 10. So we plug that in. Dx dt is equal to 10 over x times negative 400. But what is x? Do we know what x is? They didn't immediately give it to us, but is there a way we can find it? They said when s is 10, that's when we need to find these rates of change. So when s is 10, what is x? We can use the Pythagorean theorem. X squared plus 6 squared equals 10 squared. That is 8. That's a Pythagorean triple. 64 plus 36 equals 100. So when s is 10, x is 8. So sometimes the given information is, you still got to do a little bit more work to get what is given to you, okay? So they gave us s equals 10, but we had to find what is x when s is equal to 10 in order to truly find the change in the speed. And again, so we have the change in x, the change in that base distance of the triangle with respect to time is negative 500 miles per hour, okay? Again, It's negative because it's velocity. You're allowed to have negative when it comes to velocity. But the question was asking, what is the speed? Speed is always positive, so the speed of the plane is 500 miles per hour when s is 10 miles. Find the rate of change in the angle of elevation of the camera shown at 10 seconds after liftoff. Okay, so you have a camera here that is viewing the rocket. I wanted to say robot. That's viewing the rocket, and that angle is of course changing because this camera is trying to follow the rocket's liftoff. The position equation for this space shuttle is s equals 50t squared, they've given us, and then the base distance is 2,000 feet, the base of the camera from the launch pad. The variables that we're concerned with is the angle, the side that is adjacent to that angle, and the side that is opposite to that angle. Of course, we only know they're adjacent and opposite because this is a right triangle. How do we relate the opposite and the adjacent side according to that angle? Tangent of theta is equal to opposite over adjacent. They want me to find the rate of change in the angle of elevation of the camera. Okay, so that means I'm going to be finding d theta dt. The other variable in here that will be differentiated implicitly and will result in a ds dt is the change of position in the rocket, which has been given to us by this equation, s equals 50t squared. Everything they want to know is 10 seconds after liftoff. So when t equals 10, oh, and hey, when t equals 10, what is the position or the height of the rocket? 10 squared, okay, 50 times 100 is 5,000. So when t equals 10, s equals 5,000. Very important. But I know that when I derive this, it's going to have a ds dt in it, and I was not given ds dt, but I was given s as a function of t, so can I derive that? Yes, I can. What is the derivative of s with respect to time? Oh my goodness, the variables agree. So ds dt is equal to 100t to the 1. Power rule, done. No chain rule needed. So that's another piece of, quote, given information. You had to do a little bit of work to find it, but now I think we have everything we need. We have when t equals 10, we have s, and we have ds dt. So let's differentiate this tangent equation. This division of 2,000, I'm going to take that out as a constant multiple of 1 over 2,000 being multiplied by the derivative of now just the numerator, which is s. The derivative of tangent theta with respect to t. Well, the derivative of tangent u is secant squared u times u prime. So this would be secant squared theta times the derivative of theta with respect to t equals 1 over 2,000 with times the derivative of s with respect to t. We are trying to find d theta dt, so I'm going to solve for that by dividing both sides by secant squared theta. When I divide a side by secant squared theta, it's really just the same as multiplying it by its reciprocal function, right? So I'm going to write it as its reciprocal because I'm more familiar and comfortable with cosine than secant anyways. So this would be cosine squared theta over 2000 is multiplied by ds dt. But here's the thing. We have ds dt, which we could plug in here, but then we have cosine squared theta. We don't have theta, we have t, and we have s. Is there any way we can write cosine theta in terms of s? Looking at the original diagram, cosine of theta is equal to the adjacent side over the hypotenuse. And I don't even have a label for the hypotenuse. So before I find a label for cosine theta, I need to find a label for the hypotenuse. I can use the Pythagorean theorem. I'll call the hypotenuse P. So 2000 squared plus s squared is equal to P squared. And if I were to solve for P, I would square root both sides. So I'd get the square root of 2000 squared plus s squared. I'm not going to write out 2000 squared just because it's going to take up too much room. This is the hypotenuse. Okay, so can we write an equivalent expression to cosine theta? The adjacent side is 2000 feet, and the hypotenuse is this wonderful little square root. So this expression is equal to cosine theta, okay? That required us to do some special maneuvering, but this is what we're going to plug in instead of cosine theta. Okay, so I've moved the 2000 over so that we just have cosine by itself now, so that we can plug in the value that is equal to cosine. And that value, again, remember, should be squared. I'm going to plug in ds dt, which we found to be 100 t. Again, though, we are looking at specifically t equals 10. So 100 times 10. When you plug this into a calculator, you'll get 2 over 29. Now this is the rate of change of the angle of elevation with respect to time. Angle is in the units radians, so this is 2 over 29 radians per, and then time was measured in seconds. In the engine shown, a 7-inch connecting rod is fastened to a crank of radius 3 inches. The crankshaft rotates counterclockwise at a constant rate of 200 revolutions per minute. Find the velocity of the piston when theta is equal to pi thirds. Okay, remember that 1 revolution is 2 pi radians. We're trying to find the velocity of the piston. Okay, velocity of the piston is going to be the change in this x value. But how do we relate 3 sides of a non-right triangle and an angle? We do have a relationship between the sides of a non-right triangle and an angle inside. It's called law of cosines. So in law of cosines, we would label our triangle something like A, B, and C, or whatever letters you decide. You just have to know that the angle across from side B is big B, the angle across from side C is big C, the angle across from side A is big A. We have B squared is equal to A squared plus C squared minus 2 times A times C times cosine of theta. That's our equation. The crankshaft rotates counterclockwise at a constant rate of 200 revolutions per minute. So the rate at which, when the revolutions are happening, that is a change in angle. Okay, and the rate at which those angles are changing, so derivative of theta with respect to time, is equal to 200 revolutions per minute. One revolution is 2 pi, so 200 times 2 pi would give me 400 pi radians per minute. And this they've given us as a constant rate. And then they want us to find the velocity of the piston, which is related to the change in the length of x. So we'll say find dx dt when theta is pi thirds. To begin, we'll implicitly derive this equation. But wait, we actually have values to plug in. So A is 3, B is 7, and C, little c, is labeled as x. We have 7 squared equals 3 squared plus x squared minus 2 times 3 times x times cosine of theta. This is the one that we're actually going to derive. 7 squared is 49, 9 plus x squared minus 6x cosine theta. The derivative of a constant is 0. The derivative of a constant is 0. Plus the derivative of x squared with respect to t is 2x times dx dt, the derivative of the inside, minus 6 times the derivative of this product. We'll do f dg plus gdf. So f times the derivative of cosine theta plus g, which is cosine theta, times the derivative with respect to t of the f function, which is x. 0 equals 2x dx dt minus 6 times x times negative sine theta times the derivative of the inside, which is d theta dt, plus cosine theta times the derivative of x with respect to t, so that would be dx dt. We are trying to find dx dt, so I would like to group those and get them by themselves. Simplify inside here, so negative x sine theta d theta dt, and then we'll end up distributing the negative 6, so that would be positive 6x sine theta d theta dt minus 6 cosine theta dx dt. I'm going to move the dx dt terms to the left side, so that would be a positive 6 cosine theta dx dt minus 2x dx dt equals this. We'll factor out dx dt and get 6 cosine theta minus 2x divide, I can factor out a 2 here, so 3 cosine theta minus x, 2 times 3 cosine theta minus x. 6 over 2 is 3. 3x sine theta over 3 cosine theta minus x times d theta dt. Remember that they gave us, or we found, the change in the angle with respect to time, and they gave us a specific angle to check for. So that takes care of this and this, but what about x? What about these x values? Everything we're substituting in is when theta is pi thirds. So at this point, we're going to plug in pi thirds for theta in order to figure out What is x when theta is pi thirds? 49 equals 9 plus x squared minus 6x cosine of pi thirds. What is cosine of pi thirds? Well, that's the x value at pi thirds. That's actually 1/2. This looks like it's going to be a quadratic, so I'm going to bring everything to one side, see if hopefully it's factorable. 0 is equal to x squared. 9 minus 49 is negative 40. Let's factor. 8 and 5 give me 40. The bigger one needs to be negative in order to give me a negative 3. So x could be 8 or it could be negative 5. Okay, it's the side length of a triangle, so it needs to be the positive one. Now we have all the things we need to plug in. 3 times 8 times sine of pi thirds, our angle, over 3 times cosine of pi thirds minus 8, all being multiplied by 400 pi. And as we simplify this, sine of pi thirds, this right here is root 3 over 2. Cosine of pi thirds is 1/2. You'll end up getting 9600 pi root 2 over negative 13, which simplifies, if you put it in the calculator, to approximately negative 4018. The length of this side, x, is in the units of inches. And our time is per minute. So our velocity is negative 4018 inches per minute. And the velocity in this case is negative because it's representing a decreasing distance.